Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today we're going to talk about how to quickly and easily visualize mechanical connections between rigid bodies in Proteus DS. What I mean by that is articulated body algorithm connections, or ABA connections, between rigid bodies that make pin joints or sliding joints and things like that. Making sure the reference frames line up can be a little bit confusing sometimes, so it really pays to have a way to get visual feedback on the problem setup. We're going to use an older problem setup of this rigid body raft that explains a little bit in one of the other tutorials on how you can make a multi-mesh rigid body. So it has a series of cylinders here, sort of representing a pontoon raft with a couple of struts and a couple of cylinders here for sort of like an A-frame. If we just look at what is it doing in the water, so in this scenario it's just floating in a sinusoidal area wave. Now this project version is one rigid body system, and what we're going to do is demonstrate what it looks like when we break it up into two rigid bodies and have a revolute or rotational pin joint between the A-frame and the rigid body float. So what I've done in a separate project here is I've broken up the raft into two rigid bodies. So all I've done is I've removed those cylinder features from the raft rigid body, and then I've made a totally new rigid body here that represents the A-frame. And I want to highlight that these are distinctly different rigid bodies. So there's no connections with them in this particular setup. You'll see this little soccer ball thing. That's the center of mass. The rigid body frame is here, sort of along where we want the axis of rotation, and the rigid body frame is in the middle between the two pontoons over here. So they're totally separate, independent rigid bodies. If I take just for example the raft and give it an initial roll, oops, sorry, that's the frame. Raft, there we go. If I give this an initial roll, you'll see how the initial state, they're not connected to each other, they're not constrained to each other. They don't have anything to do with each other yet. I have not made an ABA connection between the two of them. So now in this last version of the project, I've made the ABA connection between the two of them. And if you've gone through the other training and video tutorials, you'll know a little bit more about the theory behind all this works. But essentially, when you make an ABA connection between a rigid body, the follower rigid body in the relationship, so if we look at the connection here, we see that the follower is the frame and the master is the raft. So the follower rigid body state is no longer this 6 degree of freedom linear and rotational state along with the velocities. It's the joint state, and the way I've configured this is that the joint axis, the pin joint axis, is along this joint frame direction here. So in the connection you specify where the joint frame is relative to the master rigid body frame and where it is relative to the follower rigid body frame, and then the joint state, in this case it's a revolute joint along this axis with 1 degree of freedom, the rotation, that is to say, of the joint angle, shows how the follower rigid body is constrained. So we go to frame and then state, and we change this to another angle, minus 30. It's going to be aiming forward a little bit. And you can see very clearly how the system, the joint is set up and how it's working. So this is a way to get visual feedback on what's happening with this. The other thing to point out is, like, now if we change the raft, state, you'll see how it's a connected rigid body system. So give it an initial roll. I'm just moving the rigid body system to show what it looks like. So you can see how they're still connected to each other. And again, that joint offset here is really like that relative rotation along that local joint axis. So working with the reference frames, it requires some careful thought and careful planning, but what's really important to take advantage of the visualizer here to get that visual feedback at how the joint's working exactly. All right, that's all I wanted to show for now, so thanks for watching.